To create a movement simulation, it is necessary to have a minimum of one variable that counts the simulation process. The standard box definition for a movement simulation is variable control. It is the variable that controls the simulation cycles. When the simulation is simple and there is only one movement process, for example, a rotation or translation movement controlled by a simple variable, this variable is used as the variable control for the movement simulation. In our example, we are going to show a connecting rod crank mechanism movement. The rotation angle variable used to rotate the mechanism's hand crank is also the control variable used to count the simulation cycles. When the simulation is complex, that is, with alternating movements, translation, and rotation, another variable is used to control when these steps should be set normally by logical conditions. In this case, the control variable is only used to count the simulation cycles, for example, 0 to 1000, and the end of the simulation is normally carried out in a logical condition. In the video for simulating the 3D movement of a robot arm, a specific variable is used to control the different stages of the movement. Increment or step indicates the variation steps from the initial value to the final value. Process parameterization processes the existing parameterization in the active group. During the process, it is possible to retrieve information from the geometry being simulated, such as points, distances, and angles. For example, calculations of the distance value or angle of a straight line during each movement cycle. Those values can then be used in other specific calculations of expressions or logical condition tests. Automatic loop. When the simulation reaches its final value, it is restarted with the control variable redefined to its initial value. It is only used when the variable control is the same as the movement simulation variable. That is, used in the simple movement process. Automatic reversion. The final value of the control variable becomes the initial value, and the initial value becomes the final value. The increment becomes negative, and the movement is executed in reverse order. Also, it is only used when the variable control is the same as the simulation variable. Show variables list. It shows the list of variables during each simulation step or increment with their respective updated values. Show user messages. Display the defined messages. The user can define warning messages with mens type commands. Normally, those messages are displayed according to logical condition tests. For instance, if a collision occurs, show a warning message. Pause on each cycle. After each simulation cycle, a dialog box is shown with continue, cancel, or break or pause buttons. Clash test. In the case of the 3D part and assembly modules, the system tests for occurrences of collisions between the faces, bodies, or components. This clash occurrences forces that specific variables receive a value different of 0. Then, logical conditions test those variables and perform the necessary tasks to handle this information. There are specific buttons to manage the dialog box property. Save a new simulation creates a new simulation based on the current dialog box data. Rebuild. Restart the movement simulation process. Move to the end of the command list. This button repositions the simulation movement command to the end of the list of commands. We will show how to create a simulation of the movement of a pendulum. Creating a horizontal line with length 50. And an ang variable that will be responsible for the rotation movement. Selecting the line and activating the rotation command. Indicating the center and angle as ang. Since ang is 0, the line will not be rotated. Creating a double center line. Creating the movement simulation command, as we are creating a simple simulation, in other words, with just one rotation movement. The rotation variable itself can be used as a control variable for movement cycles, ranging from 225 to 315 degrees. Testing the movement. As it is a pendulum, we want it to make a loop movement with reverse movement. Edit the simulation. indicating loop and automatic reverse movement. Show the variable list. See the result. Modifying Ang to 45 degrees to create a circle with color fill and a double center line. Show the simulation. As the movement occurs, I want to display text indicating the Ang variable on the screen. To do this, the variable must be created with a hash prefix and in parentheses. How can we visualize the variation in the angle of the pendulum in the screen? Creating a straight line with an angle of 315. Modifying the Ang variable to 225. An angular dimension. The dimension must be shown between the two lines. The positioning point must be defined as close as possible to the 315 degrees angle. Now show movement without screen refresh. In parts 2 and 3 will be shown how to create a simulation using logical conditions and other parametric resources.